here we have our 3D transducer. So that's inserted into the through-hole skin fitting, and protruding outside the hull is about 3 centimeters. When it comes to forward-looking sonar, to be able to see forward, we need to be able to have a clear line of sight in front of the vessels. So our transducers, they transmit sound frequencies at 200 kilohertz, and they transmit and receive these sound waves to be able to pick up all the data and analyze how the seabed is looking coming up ahead. Very, very simple box. So all we have is our power, which is again 12 or 24 voltage. Then we have our data, where we have our data input. So that's a data cable that comes from our transducer interface box. And then we have our Ethernet port. Now the Ethernet port is used to connect to the MFDs and integrate with them. But if a user does not have an MFD or wish to connect it to a display or something like that, we do also offer VGA and HDMI video output. So in that way, we're able to connect to any display that has a video input, but also on the MFDs via the Ethernet. Now, once you have everything connected, then you have our EchoPilot app that comes up on the MFD. Activate that, and then we get our visualization of the seabed. The really cool thing about having it connected to an MFD is that you get access to touch functions and zoom functions. So for example, the touch function is you can rotate the 3D image any way you like. So for example, if the user wants the standard view, it just starts as a normal standard view, kind of like that. But they can also change it up to be a side view, or they can kind of have their view from straight in front to see how everything is coming up. Now we also have our zoom function, plus and minus up here in the corner. So we can zoom in on the seabed, see how everything's looking. Now on our top corner up here, we have a new function that we call average forward depth. The average forward depth is a calculation from the data that our sonar receives. So it gets all this data from the seabed coming up ahead. And with that data, it calculates the average depth that you're actually sailing towards. So it's giving you a digital number saying, based on all this data I have of the seabed coming up ahead, your average depth that you're sailing towards is 8 meters or 4, for example. So compared to your normal depth sounder, if that says 0.0, then you've already hit something, you're stuck. So then the damage is already done. But with forward depth, that will actually tell you the depth you're sailing towards, that you're sailing into. So that allows you to not only see a visualization of what you're sailing towards, but it will also give you an idea of the depth that you're sailing towards. So that gives you a lot more tools to be able to spot something that you should be backing down from, or change your course from, or just be more cautious about moving forward. So it's a really, really good navigational tool when you're sailing in areas that are uncharted or poorly charted, or you're just basically just unfamiliar with the waters that you're sailing in. We all know that the seabed always changes. It changes constantly. And we've seen so many examples of an area where there hasn't been anything before, then suddenly a bommy is there 2 years later. And if you have your normal charting, it wouldn't be shown there. But if you had the forward-looking sonar, it would appear very clearly, and you'll be able to back down from it, and in that way avoid damaging your hull. So very, very vital tool to have while navigating. Now, in terms of forward-looking sonar, there's a term that we call the depth to range ratio, which basically means how far you're able to see depending on how much water you have underneath your hull. So if you take a commercial sonar, the way they're designed is to have as much forward view as possible, but because of that, they don't have that much forward view in shallow water. So a commercial sonar would typically have 8 times the depth to range ratio. Now, we designed our transducer and system in a way where we can get as much range as possible, especially in shallow water, because we felt that that's when you really need it. It's when you're sailing in shallow waters that you're really dependent on this type of system. So the way we designed it is, you can see the cup here, how it kind of goes down. So our transducer basically scans in a 90-degree vertical angle, so it scans straight down and straight forward. With that type of scanning, that allows us to achieve 20 times the depth to range ratio, which basically means that when you have 5 meters of water underneath your transducer, you're still able to see 100 meters ahead, which is the highest ratio of any forward-looking sonar in the market by far. The sonar will also give you a maximum of 200 meter forward range. It will be able to scan down all the way out to 100 meters in depth. So you'll be able to use that both in the cross-Atlantic, and you're able to use it when you're navigating harbors or small shallow bay areas to really have that extra safety and peace of mind when navigating.